Hello YouTube, I Fix It All here, Team I Fix It All. I got a little bit ahead of myself here and went ahead and soldered in this two plug system. Get you a close up and show you what I did, and then discuss what I like about it and what I don't like about it. Where's the okay, yeah. So previous video was about how I noticed these plugs here were way too small to accept polarized plugs. Honestly, if you look at this real close, you can barely tell the left opening there. And again, something to point with. The left opening, this is supposed to be the neutral, and that's my hot leg, neutral, and hot leg. And by comparison, we look at the plugs I got off of eBay. These openings are much larger. Put that down. They're more accommodating. Wider and taller. And so what I did was I took a razor knife and I cut these out and created the openings I needed to accommodate these two plugs right here. And I worked on, I've got 3 of these inverters I'm working on, and I'm filing down the opening to accept these new plugs. And so far, I'll take you down here and I'll show you what I got. Get something to point with. See if I can adjust the light a little better. So right there is my ground bus bar. This is my neutral bus bar. And this is my hot bus bar. And I basically reduced the profile of how deep the interface is to each outlet tremendously. Where'd the other plug go? There it is. So side by side comparison, you can see how much real estate this one took up and how much real estate I'm taking up. So I'm improving it, plus I'm making it easier to work with, because those plugs, I was having trouble getting just normal 2-prong things to plug into these. But inverters.com is a good site. They got USA customer support. They got a whole bunch of inverters in stock. And this is part 2 of the first video, but this is a hammer down inverter. They were selling these, I don't know if they still are or not, for 50 bucks a piece, 49, 48, something to that effect. Plus they have a make offer available. And then I found 20 of these on eBay for a really great price. I forget how much I paid. Let me see. There we go. 20 of them for $23.50. So you get the back shell. There's 4 different ways to interface with these electrical outlets too. They're pretty neat. But you can see all that in the previous video. What the purpose of this is to show you what I did. I got my bus bars, so to speak, done up. And I'm going to do something different on the next one. Basically because I think there's just too many solder connections going on here. I did crimp things when I attached and then soldered. so that if solder gets warm or becomes loose, the wire doesn't fly off and become a hazard. But I've got a better way of doing it. But it involves an idea of turning those sockets sideways with the ground pointed. Easier to show you. I'm probably going to end up doing that and that, and make use of these side profile holes. There's a cover that goes on the back of this. You have to understand that part, but these plugs have openings right there on the side, and anyone who dabbles in this understands what I'm talking about. You find this technology inside of long power strips, how they daisy chain outlets. How do you daisy chain that many outlets all the way up? It's because they lay a wire down in the slot and it pinches through the insulation. I don't know the technical term for it, but it basically, there's a slit in each one of those metal tangs, and when the wire is laid over, it's pushed down and slits through the insulation and makes contact with the copper for all three terminals. So you can see how you can just daisy chain several going on either end of this. Plus, it's you can do slip-on spade connectors and all that. So I'm going to button this thing up a little bit here and fire it up. See how it works. Zoom you in a little bit. And make a little bit of an adjustment. That'll work. Let's see what we can come up with. So I've got my control panel here. And I got to feed the outlets through the control panel. And then hopefully it's just a matter of snapping it in place. And it was. So there we go. There's that. Now I've got some screws I got to put on the back side of this. Find my little screwdriver here. There's four screws that holds this faceplate on. Oops, that popped out. If anybody wants anything fixed or reworked or what have you, message me. If you feel like you want to ship something to me that I could put up on the video here on YouTube and share it with everyone else. I have someone considering sending me a Harbor Freight generator that quote-unquote does not work. Just don't work. That's all I know about it. I just know it's a Harbor Freight, whatever their branding is, I forget. It's a friend of the family. Called me up and said, hey, do you want a Harbor Freight backup power system. And I thought, well, I don't need another project, but I run inverters because I got 3, so I have 2 deep freezes, and I'm going to stage these inverters in a manner to where I can pull up to the garage and hook up jumper cables to the exterior of the garage, and DC cables will pass through the wall of the garage to a common point where the DC input of the inverter is lugged and ready to go. And then I've got cords that one inverter will be, its job will be to run one deep freeze, and the other one will be to run the other deep freeze. And then the third one will go into the house, and that'll do our refrigerator and TV and internet and a box fan for the fireplace. So that looks good. A much better improvement than what was before. Got 2 of these tracks here. Check out inverters.com. The reason why I use inverters is because for outages and such is because it's just much simpler. You don't have to deal with all of the issues of what it takes for preventative maintenance on a generator, fuel going bad, carburetors fouling up, all the other moving parts problems you could have with a generator. In our house, we're very familiar with losing power, so it's not the end of the world for us. We could get by without electricity for quite a while, as long as we have enough gasoline to let cars idle. But my objective is to transition off of inverters and have my super split power up a generator head, which would be really, really neat. Alright, so I gotta pay attention to what I'm doing here. Stop talking to you guys for a minute. Just make sure I didn't screw anything up right there. No, we're good. Okay. I don't understand. There we go. So let's see what kind of conflicts we got going on in there. Everything's dressing in real nice. It's just pushing right in. Gotta find that sweet spot where everything locks in. Okay. I'll zoom you out a little bit. Let's see if you've got enough room to see what I'm doing. Put some of these screws in. Don't need this over here. If you kind of backpedal my channel, you'll see what all I get into as far as fixing things. And if you've got something laying around the house that you really just don't want to get rid of, you kind of wish somebody would have time to fix it, reach out to me. I'm not monetized either, so this isn't like something I do for a living. This thing is engineered tight everywhere. I think they had their engineering drawings set up to where everything was tolerance plus or minus. What the hell is going on there? Huh. I totally forgot I took these two back screws out because you have to. Okay. Yeah, they had their specs really tight for everything. But it's pretty impressive inverter on the inside. I've already tested these out. They work fine. They have a good consistent part number list on the inside of all the capacitors. All of the MOSFETs were not mixed and matched. The capacitors aren't exactly everyone's favorite brand. There's certainly better quality capacitors one could use, but this isn't a NASA product or anything like that. So you can go cost effective in certain areas. Let's see if I got that lined up right. Oh no. How did that happen? There we go. I got my magnets set up over there to where they'll repel each other. That way, I can just throw my screws over there and keep my three categories separated, because that's all I have right here is three separate categories of hardware. If you send me something to fix, you're going to have to figure that out as to whether you really want it fixed or not, because of shipping and all that. And I guess we could charge something or not. It depends on how difficult the thing is. whatever that thing is you've got that's broken. Blender, microwave, a toy, function generator, multimeter. Perhaps maybe you want something modified to make it better. Now that I can rally behind right there. I like those kind of products and projects. Get some feet in here. Mounting feet. Come on, line up. There we go. Got that one started. To all you parents out there, if you've got a kid who likes to take things apart, let them do it. Go to Goodwill, find something that's cheap and drag it home. Set them down on the workbench in the garage. Tell them go to town. I think I'm ready to power up. Let's see what we can do here for a power supply. Little battery charger here to simulate an automobile. There we go, there's that, there's that. Where's my cord? Gonna borrow an outlet. Okay. That's my soldering iron. It says it's putting out 14 volts. No smoke. Now you'll see it live if it smoke checks. Are you ready to power on? There's two power switches. You got one on the front. One on the back and then one on the front. And I think this one is power for the front. Okay, there we go. Need something to prop this up with. It says 14.2 volts. Find something better to prop it up with. Yeah, you guys can see that easy enough, I'm sure. we'll set the multimeter over there. See what we come up with output voltage. I don't like those blue lights. So it's got a power. Why is it drawing 62 watts? Not sure why that's happening. That don't make any sense at all. Wonder why it says 62 watts. Huh. These are brand new to me, so an unloaded inverter, it might be a misnomer. It just might not be correct. Let's see what we got. We got volts AC set up here. Let's check our output. Go from ground to hot leg. I'm not sure what's going on there. What the heck is going on? Alright, hang tight, I'll be right back. Okay, so there was nothing wrong. I think I remember, it's been a while since I powered these up. I think in their resting position, no load, they might not even say 0. They may have some sort of wattage displayed. I went ahead and simulated hooking this up to a car idling right now. So I can go over here and see that my input voltage all the way up to the workbench now is 14.6 volts. I have a jigsaw here plugged in. It says 3.2 amps. What is that? 3.2 amps. 3.2 amps times 120 volts is about 384 watts of energy. If I divide that by 14.7 divided by 14.7 volts, that's 26 amps worth of draw on my car battery. That's how much. That's pretty decent load, especially with being a motor load on a modified sine wave inverter. But this is an old skill saw made in the 80s. I've got 2 or 3 of these. I don't know where this one was made. Let me see. This one's made Chicago, Illinois. SB Power Tool Company. But I'm expecting about 350 watts wide open. Oh, I gotta change over to wattage. $378 watts was the highest it went. So that's what we expected. It's working fine. Let's test the other outlet. Make sure it's operational. That little power supply up there, the yellow one that I was using, let me adjust you a little bit. It just didn't, that guy just didn't have enough output power to keep up with this skill saw. I think this inverter is designed to, if there's no load, you're not going to have no AC mains coming out. I think that's the way it works. Oh, let me go to AC. Yeah, I'm just not sure. I'm gonna run the, see if the voltage changes. Now this is a not a true RMS, so let's go to another multimeter, because this is giving me a reading that I don't want to open the discussion about that topic just yet. I'll just leave it alone. Now here's a true RMS multimeter. Seems like I've left the battery on that one. I don't know what happened. Let's get my other true RMS meter. There we go. Let's go to AC volts. Let's see what I can get there. Huh. Okay, so this is reading with no load on. It's telling me I got 119 volts. Wonder if I can pokey this and make it stay. See what our voltage drops to. And that says it dropped down to 116 with a true RMS meter. So again, that's a different topic. Why did one meter read one way and the other one didn't? But hey, my outlets are repaired. I can use these with plug cords without worrying about ripping the face off when I unplug things. Hang tight while I put the cover back on. So there we have it. All is well, it is well. It's one of those times where you don't believe your meter. I remember when I was going through BEE class in the Navy. And it was so hard for those instructors to get us new recruits to believe our meter. I was going through aviation electronics, and they put you through some beginner stuff first. They had screamed, "Sailor, believe your meter." Every time I run across a multimeter that's not true RMS, like the meters they made us use back then, probably would have given me the same low reading. RMS standing for root mean squared. These inverters put out a square wave signal. And what you'd prefer to have is a sinusoidal waveform, which is a sine wave. But in order to get that, the price goes up. And the container gets bigger. And they're using MOSFETs and these things to switch the DC power on and off and flip its polarity and switch that reverse polarity battery voltage on and off really fast and feed them into a transformer which steps that voltage up, a step-up transformer, 2 or 3 of them, and all kinds of other whistles and bells until you get 120 volts AC out the other end. But it's not really pure AC, it's a modified sine wave is what they call it. And I'm sure it's kind of dirty, but yeah, you got to be careful with these.